Alright, so year 10, this is our last video for algebra. This video is going to do some completing square. Okay, so we are going to use another formula we have learned in expansion, but we are going to use this for our factorization as well, right? Okay, so let's see. Okay, so do you still remember that? So that's the expanding of a perfect square. So if you got like a binomial p plus q or p minus q square, then you will have the p square plus or minus. It depends on the sign in the bracket. If the sign in the bracket is plus, then it will be plus. Okay, otherwise it will be minus. P square plus 2pq plus q square. So this is a very useful pattern for some of our coming work. Okay, so if you remember this, then we are going to apply this for our factorization in the forthcoming questions. Right, but this is not the main purpose of this video, but you need to know this, right? Okay, so for example, if you are asked to factorize the three terms, of course we know for the terms like this, you can always use that a method of decomposition to separate the middle term to two terms, and then you got four terms, and you do the grouping and you factorize. Okay, so that happens in our video 7, and in our video I think it should be 6 and 7 about the factorization of monic quadratic and non-monic quadratic. But this time, since we have this formula, so possibly we're just going to use like the most convenient one. So if you can see, the first term is x squared. Okay, so it's x squared plus 2 times 5 times x plus, okay, the last term is 25, so it's 5 squared. Okay, so let's look back. If you copy, okay, this one, and you just try to put here to compare what you see. Okay, so this is plus, so I'm going to delete that's minus. Okay, so do you see that? That's x just like a p, and you got 2, and you got x here, so it's p, and also you got another 5, so that's 5 is actually q, and followed by that's q squared, that 5 squared. We got 25 is 5 squared. Okay, so if you got this, what we call an identity here, so that means your expression can be factorized as p plus q squared, right? So if you see that pattern, so that means these three terms we can just factorize them into this form. Okay, so remember you have to match each term by using that identity, right? Okay, so let's move on to here. Okay, so for this one, let's see, the first term is x squared, and you got 2 times 3 over 2 times x plus 3 over 2 squared, right? So when you compare with this one, again, let me move up over here, if you can see it. Okay, so this time is minus. Okay, so I'm going to use this one. Okay, so see, when we have p squared minus 2pq plus q squared equals p minus q squared, alright? Okay, so p is x, you got 2, p is x, the middle term, and q is 3 over 2. The last term, 9 over 4, is 3 over 2 square, right? So that's q square. So you basically match the right hand side. Okay, so that means these three terms we can always factorize them into this form. Okay, possibly you might need some time to digest this because it's not quite familiar with you, but you just try to understand this. The way we use this identity to do the factorization here. Try to understand this because that's very important for you to make sense of the rest of the video. Okay? Right. The purpose to learn this is for us try to rewrite this form into the form of this one. Okay? So you got x squared plus bx. You need to rewrite that into x plus a number. So this here is a number. So put a number. And also here another number could be difference. A number. So can we convert this x squared plus bx, these two terms, into something we call x plus bracket square plus another number? Okay, so the process by doing this, by converting x squared plus bx into this form, what we call is a method of completing square. So the process is called completing square. So that's the topic of this notes or the video, right? So that's what we call completing square, because you see a complete square right here. So you need to rewrite the form into complete square. Why do we need to do that completing square form? Okay, so that's the purpose we will find out at the end of this video, I promise you. But at this moment you need to be a bit patient to learn things as I have said. Alright, okay, so there are a few steps. Okay, so the first step is for you to rewrite that x squared plus bx as x squared plus 2 times b over 2 times x. So okay, so you need to create a 2, and also I need to create another number. Of course, you see 2 times b over 2. 2 times b over 2 is actually b. Alright, so nothing changed, but I should say essentially that they are equal. Alright, but the form is changed. Okay, you change the form for step 2. Okay, so let's see if I give you an example like x squared plus 6s, then what are you going to do? The first step, you are going to write x squared plus 2 times 3x. Okay, you see that you need to create a 2, you need to create 3. So you need to ask yourself, how could I rewrite that 6 into 2 times something? So every number can be rewritten into 2 times something, right? In general, if that's a b, then you can always rewrite that into 2 times b over 2. Just like 6, you can always rewrite that into 2 times 6 over 2, which is 3. Okay? So the idea to rewrite this into this form is for step 2. For step 2, because you got that b over 2, okay, let's use the, okay, because you got that b over 2, then you will add that b over 2 square, and then you immediately take away. Okay, so that's quite strange, so I need to explain to you. Okay, so the first two terms, x squared plus 2 times b over 2x, essentially is just what the question about. But then you, out of nothing, you plus a bracket b over 2 square. But since that's out of nothing, it should not be here, right? Otherwise, they are no longer equal to previous expression, so you need to take it away, right? Just like in any equation, if you add something, if you don't want to change the equation, you need to take it away, all right? Just like here. Okay, so you see, when we got x squared plus 6, we rewrite them into x squared plus 2 times 3x. Okay, so we focus on that 3, right? So you got that 3. Still remember how could we get that 3? You rewrite that 6 into 2 times 3, and so that 3 is important here. And this expression, you are going to rewrite that into 2 times 3x plus 3x, 3 squared, right? You plus 3 squared. But since there's no 3 squared here, so you have to take it away. Otherwise, you compromise that equal sign, because the two expressions must be equal, right? So I know this is quite complicated for you, so possibly you need to try to think about this for some time. For some students, it might take you like 5 or 10 minutes to understand this, but that's the advantage of the video. You can always stop now and just go back to try to think about the whole thing. Okay? Alright? Okay. If you want to see the whole picture a little bit bigger, a little bit complete, then yes, it's okay. I'm going to do the rest of them. Alright? Okay, so after you got this, that will give you the step 3. Okay, so remember, after step 2, you create how many terms? You got that 4 terms. And the first 3 terms is crucial. Why? When I highlight that first 3 terms, how does it look like? Okay, so let me move that towards here. Okay. Remember this one? So let me copy it and let me place right here. Okay. Okay, so see, they actually look quite similar, right? So you got x squared, that just like p squared. You got 2p cubed, that just like 2 times x times b over 2, right? Okay, and plus another square, q squared. Okay, so the first 3 terms actually looks like the 3 terms on the right hand side. Okay, so but if you got 3 terms look like the right hand side, you can always factorize them into a complete square. So that's why you could factorize these 3 terms into, okay, factorize a perfect binomial square into the things here. Alright. So the first 3 terms is factorized as a complete square, and of course the last term, which should be left outside the bracket, and we should keep that term as it is. Right? Okay, so let's see what happens when we go to the example. Okay, so you see, I got x squared plus 2 times 3 times x plus 3 squared. Okay, so when we look at the first 3 terms, just the first 3 terms, when we look at the first 3 terms, it actually agrees with the pattern of the previous identity. You got p squared 1 plus 2 times p cubed plus q squared. Alright, so you got x squared, you got 3 squared at both ends, and also the middle terms 2 times 3 times x. Okay, so if you got 3 terms like this, you can always make them into a perfect binomial square, x plus 3 squared. Alright, minus 3 squared. Okay, so that 3 squared is here, so that's why it's important for us. When you add that 3 squared in the step 2, you need to take it away immediately. So keep that 3 squared outside the bracket, and of course that's 3 squared. When you simplify, it becomes 9. Okay, so let's see, have we finished the question here? With a bigger picture, you see that what we have done. Okay, so the purpose is to convert this one, x squared plus 6 plus bx, into a complete square plus a number. Okay, so we use x squared plus 6 as one example. Okay, and x squared plus 6x first, we rewrite them into the form like x squared plus, rewrite that 6x as 2 times 3 times x. Then okay, based on that 3 you created, you plus 3 square, and then you take it away because you need to keep that equal sign valid. Alright, and then after that you can factorize the first 3 terms. Into a perfect square, x plus 3 square, and lastly you just simplify them. Okay, so here's the purpose. From that x squared plus 6x, okay, you got all the way to this last step. You change that into x plus 3 bracket square minus 9. So that's what we call completing square. Okay, all right. Okay, so if you are still not quite sure, that's very natural. You just need to be patient and learn as much as you can, make sense as much as you can, right? Okay, so then I'm going to show you how to do 2 examples. After that, possibly you have a better idea what we're going to do. All right, so the question would be like this: complete the square for the following expression. Okay, so the first one, x squared plus 4x. So what I'm going to do, first I'm going to rewrite this one as possibly I should copy the question, sorry. Alright, so I just copy the question. Okay, so the first step, I'm going to rewrite that 4 into 2 times x. It seems I'm doing nothing here, just rewrite that 4 and 2 times 2. But then you create 2 times 2, so this 2 is important here, because the next step I'm going to do is, you got 2 times x, I'm going to add 2 square over here. You add 2 square over here, right? And at the same time you have to take it away, because otherwise they are not equal, right? And okay, so how come I get that 2? Because this 2, right? Okay, right, so the first 3 terms will look like the things here. Remember this identity? I copy here again to make sure you can see the connection. Okay, so you got this term, right? You got these 3 terms. If you got something p squared plus 2pq plus q squared, then you could factorize into a complete square. Do we have that? We got x squared, so that's just like a p, plus 2 times x times 2. Yes, or I write 2 times x, but actually the same. So you got 2pq in the middle, and also you got that's 2 is 2 squared. Alright, so that's why you have to add that's 2 squared. Okay, so these 3 terms can be factorized according to the identity, can be factorized as x plus 2 squared. Okay, can you see the connection here? And of course you have to keep that another 2 squared outside, because that's what we hold equality, right? And you just do a little bit simplification of the last term. Okay, so that's what we call the complete the square. So you got square in front of it, possibly you need to minus a number all right, or plus a number. Okay, so that's the first one. Okay, so how about the second one? Okay, so second one is a little bit difficult. So let's say this one. All right. Okay, for this one. Okay, so let's rewrite them. First step. Okay, 5, we need to rewrite that 5 into 2 times something. 2 times what equal to 5? Okay, you might try to do it by using calculator. If I ask you 2 times what's equal to 5, you might try to use 5 divided by 2 by using calculator. Then you might see 2.5. But I would prefer to use fraction. 2 times 5 over 2 equals 5, right? Okay, so that's the first step. Okay, our second step, so remember what's the metric number here. So here's the metric number. Alright, so our next step would be x squared times x squared minus 5 over 2 times x plus 5 over 2, the whole square. Okay, you need a bracket for that because that's a fraction. Okay, but of course you add that for nothing, alright, according to that's 5 over 2. So you have to take it away immediately. Okay, and again remember the first three terms. Again, we're going to use the identity we just used before. Okay, so that's this time is minus, so p minus q square equals to p square minus 2pq plus q square. Okay, so if you compare, you see the first three terms satisfy the right hand side with the minus in the middle term. Alright, so that means the first three terms, what we are going to write, x minus 5 over 2 square, right, and plus what, minus, okay, 25 over 4, okay, because that's 5 over 2 square. Okay, good. So that's basically what we're going to do with the completing square. Feel better now for these two examples for demonstration, right? Okay, so if you need more time, just take your time. So this is complicated, right? Okay, so in the examination, this type of question will be most likely complex familiar, right? So you need to be prepared for that. Okay, right, so let's move on to our practice. So I'm going to give you two practice questions for you to try to complete the square. Okay, you might take some time, you need to try by yourself, okay, to see if you really understand how to do each step. Okay, so I just try to give you a start for the first question. For the first question, it's a little bit tricky because you got x squared minus 2x. It's already 2, but you still need to create that 2 times something, right? So the first step, okay, I just give you a start for our first question. Okay, so it would be x squared 2 times what equal to 2? 1. Okay, so even that's 1 is important right here. Okay, so just try to follow our previous method to see if you can do the completing square, which is the most difficult part of algebra in year 10. Okay, so I'm going to give you some time. Okay, so here's the answer, right? Okay, so you see for the first one, okay, so it's x squared minus 2 times 1, so that's 1 is important, so 1 is here, so you need to have 1 square, but you need to take it away immediately. Okay, so for the first three terms, you can complete the square into x minus 1 bracket square minus 1, right? Okay, for the part B, so that's 3. So it's so for 3, you need to think 2 times what's equal to 3. It should be 3 over 2. So 3 over 2 is the key number. Okay, so for the next step, you need to add that 3 over 2 square and then take it away. The first three terms you can always group them into a perfect square, which is x plus 3 over 2 bracket square minus 9 over 4. Okay. Alright, okay, so that's it for our first part of this completing square. Okay, so let's move on. Okay, so sometimes, so in the previous questions, we got only two terms, and you need to convert them into a completing square form. Okay, but next we're going to give you, okay, three terms. So can we try to convert this into a completing square form? Okay, let's see. Okay, so actually everything's the same. So the idea is do not touch that C until the completing square has been done. So that C would be always like a bystander. Okay, so it does nothing. It just sit aside until everything finishes, and it just appear in the final step for the final simplification. So you just keep that two outside, right? Okay, out of the work you are doing. Okay, so everything will be focused on the first two terms. All right, so like for this one, x minus 10x plus 2. Okay, so the first part, just like what we have been doing for the previous one, you need to rewrite the thing into x squared plus 2 times b over 2x plus, but of course here you got c, so you need to rewrite that into, okay, x squared minus 10x plus 2, okay, into x squared minus 2 times 5 times x, so which is the key number here. The key is 5. Okay, so the 2 is still 2, so 2 is nothing, just sitting there waiting for waiting for the competing square to be finished. Right, so for the first three terms, so next line, step 2, you are going to do the same thing. You are going to add that b over 2 square and take it away, right? So remember, after the first step, you got that 5, which is a key number, so you need to add 5 squared, take 5 squared. You see the 2 still here, doing nothing. Yeah, okay? So, and then focus on the first three terms. If you focus on the first three terms, you know that the first three terms can be, okay, they can be factorized into a complete square, right? But this time, the middle terms will be negative. So it's x minus 5 squared. Okay, of course, you got minus 5 squared already outside. You got plus 2. Okay, so here, until that last step, you don't touch that 2. Okay, so in the last step, you need to get that minus 25 plus 2 becomes minus 23. So you see, actually everything will be just like what we've done before, but you just get one extra constant, which is idle for most of the time. It appears only in your final step, final simplification, right? Okay, so let me to do this question. There are two demonstrations. So first one, right, it'll be an easier one. Okay, so you need to complete the square. Remember the question is about completing square. Okay, so I copy the question. Okay, and just like before, I need to rewrite that x term into 2 times what? Because that's 4x, 2 times 2x plus 9. Okay, remember here, you got your key number. Okay, next line, x squared plus 2 times x. Since that 2 is the key number, you add that 2 squared and take it away immediately. And you keep that 9. So 9 doing nothing, it's idle. Right? Right, so, and then you could see for the first three terms, you could group them into x plus 2 square minus 4, because minus 2 square, plus 9. Okay, so minus 4 plus 9, so that's when the last term, that's 9, come to alive, so you could simplify it. Alright, so here is what we've got for our first step, for part A, sorry. And how about the second one? Okay, second one, look. So it would be x squared minus 2 times 5 over 2 times x plus minus 1. So what's the magic number? So the magic number is 5 over 2. Okay, then you are going to do x squared times 5 over 2 times x plus that's 5 over 2 squared in the bracket because that's a fraction. Okay, 5 over 2 squared minus 1. Okay, so you see that how about the first 3 terms, and the first 3 terms will be a complete square in terms of this. Okay, so the first 3 terms, and the last 2 terms is like this. Okay, you might use your calculator to do that's minus 25 over 4 minus 1, so that would be minus 29 over 4. Okay, right, so here's what we've got for our second question, right? And let's move on. Okay, so you see what happens here. The only difference from our current example, okay, from our previous example, is like you got one extra number, you got 9 over here, you got minus 1 over here, but actually they do nothing until the last step. That's what you need to learn. Okay, so it's not that difficult, right? So let's do this one. X squared minus 2x plus 3. Okay, you need to complete the square, so that's practice 2, right? Okay, so just pause the video now. You try to finish this one and check your answer with mine after that. Alright, so give you some time. Okay, so here are the answers. Alright, okay, so for A, just make sure that you know that 2x should be rewritten as 2 times 1 times x. Alright, and then you just add 1 square by take away 1 square plus 3. So that's plus 3 is always like an outsider doing nothing. It does nothing until the last step. Alright, remember that? Okay, for the next one, the 3 is so for 3x, you need to rewrite them into 2 times 3 over 2x. Okay, so here, let me highlight the key number in both cases. Okay, in this case, the key number 3 over 2. Okay, so that's why you see 3 over 2 square, take over 3 over 2 square, and 3 over 2 in the bracket. Here the key number is 1, so that's why you see 1 square right here. Alright, so you got the answer. Okay, all good? Alright, so that's simply okay for the completing square of second type. Okay, so essentially they are the same, but just got more to do. Right? Okay, so I promised you before why do we need to learn this completing square? The ultimate goal is for us to factorize the monic quadratic. Okay, why? Okay, because sometimes we might have some quadratic expression which is impossible to use our previous skills to factorize. Still remember how to factorize the things like this? Okay, so in our previous video, we know that if you got things like this, you need to check the product between A and C, which is 1 times minus 1 is minus 1. Okay, so and then you need to see what combination of factors do we have, and so you need to find a pair of numbers. When they multiply together, they get A times C, and then you have to make sure the sum of the two numbers give you the middle number, right? Okay, so A times C is -1, so that's not many choices. So the only choices is you rewrite that's -1 into 1 times -1. But you know, when you add 1 with -1, it can't be -2, right? It's 0. Okay, so that means this expression, okay, cannot be factorized by using the method learned before. That method is called by using the method of decomposing. Okay, so that method of decomposing means you need to decompose the middle term into two terms, but now it's impossible. So sometimes our previous method doesn't work. So, but if we still need to factorize this, what can we do? We can use completing square. Okay, so let's see. For example, if I got that x squared minus 2x minus 1, which cannot be factorized by previous method of decomposition or decomposing, right? And what you can do, you can rewrite that into the completing square form. So here is the completing square, right? So this process is what we call completing square. So you got a square minus something, okay, and that completing square form can enable us to further factorize this, because we have learned that before in last video. If you got square minus a number, even though that number is not a square number, we can still try to use the short form. Okay, if you forgot that, let me remind you over here. Just create space for me. Okay, so if we try to think about how could we factorize this. Okay, so last time we've learned something like this. If you got 2, which is not a square number, but you can always write that's 2 into square root 2 square. Okay, then you think about an identity of the difference of square. If you remember that, if you got a square minus b square, you can always rewrite them into a minus b, a plus b, right? So that's x minus 1 square minus square root 2 square. You can always treat them as a square minus b square, okay? So you will have the form like this. Okay, so here's the form. Okay, of course you can simplify them. That's what you will get. Okay, so that basically factorize this very difficult expression. So that's how we get this. So that's a factorized form. Alright? Okay, so that's why we need to learn completing square. Without completing square, it's impossible for you to do the factorization in our last step. That's the reason. Okay. Oh, good. So let's try this one. Okay. So this time it's not just completing square. You need to factorize the quadratic expression. And in the examination, they are going to ask you to by completing square first. Okay. So what are you going to do? You need to complete the square. So first, we need to complete the square. To completing the square, you need to rewrite the middle term as 2 times 3 times x. Okay, and our next step would be, okay, what's the key number here? The key number should be 3, right? So you plus 3 square, and you take it away immediately to make sure the equality still holds. Okay, so the first 3 terms, you got this one. The last 3 terms, you got minus 9 plus 5, right? So it will give you minus 3 square minus 4, okay? Okay, so this time, how about 4? Is 4 a square number? Yes. So 4 is a square number. So you don't need to write things like this. Okay, because 4 square root of 4 is 2. Okay, so you just rewrite this as 2. So if you do the completing square, you just stop here. Okay, if the question is just about the completing square, so completing square, finished here. So completing square finished here, so it's done here. But you still need to do the factorization, right? So you need to continue. So you got that into a squared minus b squared, and you will have x minus 3 minus 2, x minus 3 plus 2. Okay, and of course you need to simplify this. And you will get this one, right? Okay. Okay. So from here to here, that's what we call factorization. Okay. So completing square stop when you got x minus 3 squared minus 4, but you need to continue, right? Because the question asks you to factorize this one. Alright, okay, so you see what we've got here is x minus 5, x minus 1 looks similar, right? Look familiar for you. Alright, so because actually for this one we can do it another way. So let me show you how could we do it another way. Okay, so let me show you here. So you can make a comparison. Okay, so let's say we try to factorize this one without completing square. Is that possible? Without completing square, it is possible. Okay, so let's think about how could we do it without completing square. If you are not using completing square, you are going to use decomposition, right? So that means we try to separate that middle term into minus 6 into 2 terms. Still remember how to do it? Okay, try to remember that. So a times c, a is the coefficient of x squared, c will be the last constant, so it should be 5. Okay, and the middle terms minus 6. So you need to think about a pair of factor which of 5 which are both negative. So you need to have minus 1 times minus 5. Okay, so this is the only possible a pair of factors for that's 5. Okay, and both of them are negative. So and you need to check whether minus 1 plus minus 5 equals minus 6, and of course they're equal. Okay, so you see the product of minus 1 minus 5 equals the last term, and the sum of the two numbers equal to the middle numbers. Okay, so that means minus 1 minus 5 is the key number. Okay, so next we're going to do this. Okay, so x squared minus 6x plus 5. Still remember the decomposition. You need to decompose that minus 6 into 2 terms, into minus 1x minus 5x. So okay, so minus 6 into minus 1. If you write 1 here, that's okay. Minus 1x minus 5x plus 5. Okay, still remember that? Okay, then group them in the first 2 terms, x minus 1, and the next 2 terms, last 2 terms I should say, you take minus 5. Remember, change the sign, and you see that 2x minus 1 is common binomial factor. Okay, you see, when you compare this method to the completing square one, you got the same answer, right? So that's how we could use difference method to arrive at the same solution, the same answer, right? Okay, but of course because the question has asked you to do that factorization by completing square first, so you have to use the completing square in the examination. So that's why you can't rely on just knowing how to do factorization by using method of decomposition. Okay, and the more important thing is that sometimes method of decomposition doesn't work, like what we've shown you in our previous illustration here, because for x squared minus 2x minus 1, this is impossible to use a method of decomposition. It has to use the method of completing square, and that will happen to our part B. Okay, let me show you. Okay, x squared plus ax minus 3. What happens here? Let's see, x squared plus x 2 times 4 times x. Okay, so what you need to do now is plus 4 square minus 4 square minus 3. Okay, so because that's 4 is the key number. Alright, so the first 3 terms you can go to into perfect square. Minus 4 square minus 3. Okay, minus 16 minus 3, which is x plus 4 square minus 19. Okay, x plus 4 square minus 19. Okay, what do we get? Okay, so if you just doing completing square, that's the end of it, but you need to do the factorization. So 19 is not a square number, but we understand that we can always use the short form. If it is not the square number, you can use the short form, and you could always do things like this. Okay, then that's done. Okay, so for part B, it's impossible for you to use that method of decomposition. You can try by yourself, but it's impossible. Okay, sometimes it happens that method of decomposition doesn't work, but method of completing square always work for in terms of the factorization, right? Okay. Factorize the following quadratic expression by completing square first. Use short form if necessary. Okay, so you see the same question here. So I might give you some time to try these two, and we compare our answers, right? Okay. Okay, so here's the answer, right? For the first one, okay, basically the first part is just like the completing square. Okay, so from from here, okay, so from here is the factorization. Okay, because that's 16, you can rewrite that 16 in 4 square, so it could be have two factors with integer numbers inside. So for this one, actually, you could say if you want to use method of decomposition, you can use it. You will have the same answer, right? But for B, okay, it's a big difference, because that's 18 is not a square number, so you have to use short form, okay, to make it happen. Alright, so if that's short form, then when you factorize it, so the final answer you will see square root 18. So for part B, you can't use method of decomposition. You have to use method of completing square for the factorization. Alright, okay. So that's it for all the contents in our algebra. Okay, before we finish, let me remind you that you can have you need to do that practice 4 for this completing square exercise. I got a few questions for you from the textbook. Also, you can have the answer to check with. Alright, okay, so that's basically the exercise for the completing square, and also that will only be 2 videos for sorry. So after these 3 videos, we still got something like the revision exercise, which is which will be useful um, for your preparation of the assessment. Okay, so here's the week 1 review questions with answers. All right, and there's another one which is week 2. Okay, review questions and answers right here. Okay, so all you need to do is try to do them as many as possible to prepare for the assessment. All right, so I know that lots of questions, but that's the nature of algebra. You need to do more when you've just learned it. If you put it aside for a very long time, then it would becomes more difficult for you to catch up. Okay, if you have any problems and questions, please email me, or if you finish some homework, please email me as well. All right, so okay, see you next time.